Alright, welcome back, Science 7. Today we are going to start our new chapter, 1.2, which is mainly about sudden Earth events. If I give a little recalling, in past chapter 1.1, we talk about why scientists, especially in this case geologists, require models to study the planet Earth. The reason being is because when it comes to Earth, it is just too vast, at one point too complex, or because it's too vast and unexplorable yet. That's one of the reasons why we have to use indirect evidences to understand about our planet. And at the same time, we also learn about how gradual events happen, like mountain range. And talking about mountain ranges and hills, we also learn about different layers of the Earth. Now let's go through specifically sudden Earth events. Generally, it leads to natural disaster. Before I get things started, I think it is more wise for me to use my Google Meet time to go over some of those textbook questions, because not everybody may need to go through everything. And the video can get too long once I include all of the detailed answer. So please visit my Google Meet if you want to go over some of those questions. So the very first part of today's lesson involves science log activity number 5. I want you to pause this video and write down any 2 to 3 Earth activities that you see on the news or articles. Nowadays, probably Twitters. Once you did, let me go through some of those examples that I can think of. First thing first, the one that we have been discussing all the time, volcanic activity. It can be one of them. And there are numerous choices that you can have. You can think about earthquake. You can also think about something that happened on oceanic plate, which can be tsunami. If it's weather specific season related, you can think about typhoon season, etc., etc. When it comes to sudden changes, ladies and gentlemen, related to Earth activities, you guys may notice that all of those activities are quite vigorous, violent, active, destructive, and so on. You may notice there are a lot of damages that happen even during, after, or some rare cases even before. For example, today we are going to learn that most of the earthquakes actually have to have 2 different types of earthquake. And one of them is a little beginning, weaker one. The second one is a real one, something like that. Similar parts happen when it comes to tsunami too. Today's main focus is earthquake, ladies and gentlemen. Earthquake occurs when tectonic plates break or move suddenly. So I'm going to highlight this specific plates in here. So that means it can be oceanic plate or it can be continental plate. Earthquake generally cause shock wave. The reason we have a shock wave is because earthquake involve trembling or vibrating. Those motions, wave motion, caused by the sudden release of an energy because of an impact. We call it momentum. That slowly build up at certain area, and as soon as the plates break apart, that's when the impacts go on the ground, which is our Earth crust. And large masses of rock in the crust move and sometimes become locked together. and stuck together. Those are extreme situations. I'm not talking about mountain formation. Mountain formation is quite gradual. So in this case, the struck situation is the one where sometimes it does involve any type of rock slide situation in addition to demolish of the building because of the earthquake. It is possible. When it comes to earthquake, one thing that you need to understand is the force direction and pressure. The pressure basically forces the rock first to change its shape. So if you think about the diagram below, can you see that it's more about the example of shear? If you guys remember in Unit D, shear is when you have forces applying two different locations with two different directions. So if you think about my one on the top section, you know that it is coming from west to east. On the other hand, the bottom part is from east to west situation. With this shearing forces, the most pressure and stress goes in the middle. So that's why when it comes to an actual impact, we have a ripping occur. And with that impact, can you see I have a wave impact down there, the shock wave? This is the one that creates trembling, vibration, and so on. One thing that you need to understand in earthquake, ladies and gentlemen, is something that I like to call it as focus. When you hear focus, it is actually equivalent as center. It is center of the shock. Focus is the first place that the rock breaks below the surface, and it is the beginning of the earthquake. Unpredictable, of course. We may predict certain pattern because some of those plates direction, they're slow, but they're steady. The sudden breaking of rocks at the focus release wave energy, and that goes through Earth. And one thing that you need to understand at this point is when it comes to, can you guys put this? Solid transfer wave better than liquid. That is a reality. Because of this, as you may know, and you can demonstrate this a little bit, if you dive under the water and try to call someone with the distance, it doesn't transfer as much or as fast. On the other hand, imagine you put one of your ear directly touch on the top of your desk, and I want you to have a little knocking sound. So put your ears on the desk and then have a gentle knock. As you may notice, the sound seems very, 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 very amplified. And the reason being is because in solid, they transfer wave energy way better. Because in solid, if you guys remember from Unit C, particles are all adjacent together. They are all locked, ladies and gentlemen. So if there's a one area that has a shock, it's gonna bring all of those shock multi-direction ASAP. This is one of the reasons why earthquake focus, as soon as we detect the focus, the impact will go really fast towards the ground and towards the building. Let's talk about types of the waves. So first part, we learn about focus. Focus was a start of the breaking. The second part is actual wave impact. Wave can move three different mediums. Like I mentioned, solid, liquid, gas. The order is gas is actually the least, fast speed, liquid, then solid. Solid transfer energy is the fastest. So Shaking that you feel on the ground, if you experience the earthquake, it's caused by those waves that is moving through the ground. And in seismic wave, there are two types. One type goes like this. Imagine, I'm gonna change the color, pushing, pulling direction. That's one type of a direction of wave. We have a hard time seeing that in real life because most of the wave is what you see in sea. We call it transverse wave. The wave go up, down, up, down. But in fact, the wave is actually passing left and right. So what you see on B is the same direction. What you see in C, those directions are 90 degrees to each other. And we're going to look at it in detail right after. First form of wave is P wave. And that's the one you can connect it to the one at the bottom. One in the middle. The one that shares same direction. S wave, on the other hand, which generally is more destructive one, this is the one where 90-degree direction. Wave is actually move up, down, but in fact, the direction of the wave is actually coming from left to right, right to left. And if you think about left to right versus up and down, that gives you 90 degrees. So I want you to look at the GIF that I posted below over here. This is a P wave. Imagine you have a slinky. If you have it, you can actually demonstrate. I want you to hold one of the end using your hand and then push it and pull it suddenly. Then you will see that there will be a wave that is going front and coming back, because wave can go forward and reflect it back. If you don't have a slinky, it's kind of hard to imagine in your head. That's why I prepare our good old GIF over here. As you can see, I'm gonna wait a little bit. I want you to focus over here. Can you see there's a thin end that go left to right from this PowerPoint slide? That's the direction of it. And while it's moving, I want you to look at the fence damage. It actually have a little damage as time goes. P wave is known as primary wave. It always happens first. And it's not as powerful. It's shaking the ground back and forth as the direction of the wave moves. And this is an enlarged version of it. Can you see again that? Let me just go. It starts now, and this thick wave are going on the right side as time goes. And if that amplitude we call, if it's get really fatter like this, that's where the most damage occur. S wave, on the other hand, is what we have it for the second time. We call it secondary or shear wave. This is the dangerous one. First of all, it shakes the ground up and down, ladies and gentlemen. This is one of the reasons why most of the building break apart. Like I mentioned, it is 90 degrees to each other. We call it perpendicular direction. And this is what happened. You can demonstrate this in water. I want you to think about a little pond. You stand on the side, and there is a kid who throw a rock. Then what do you think is gonna happen to the wave? It's gonna go like this. This is a dropping spot. But on the other hand, if you look at it from the side view, the water will look like this. As soon as the stone is dropped at the center, so stone drop, then water will actually go up and down like this. Secondary wave is dangerous precisely because of this. The impact is actually, so wave is going left and right because wave disperse if you drop the stone on a pond. But when you look at side wave, the wave is actually going up and down. And buildings and constructions are not built to resist that. So if you look at the damage, it's even more dangerous. I want you to look at how, can you see the wave as it going up and down like this? Please follow my laser controller. Because of this up and down motion, please look at how unstable the trees are. At least trees have strong root. I mean, buildings have strong foundation most of the time, but if it's not built with the material that is flexible, you will notice that bridges, buildings, they're gonna fall. So know the fact that P wave start first, which is along the line of the wave, then followed by transverse wave, which is S wave, which go perpendicular direction, up and down. Now, third part is what we call epicenter. Epicenter is, first of all, known as the point of the surface that's directly above the focus. So if you look at this diagram, can you see that I have focus in the middle, at the bottom part. Epicenter is direct upward, and the spot that is exposed to the air. That's what epicenter is. A lot of geologists try to, I'm going to erase this part, try to focus on epicenter over here. Because the thing is, if you locate epicenter, then you will actually predict how fast people from this town or rural area over here should evacuate to certain area. And this is something that people have to have it in your mind. From focus to epicenter location, this time really doesn't take a long time. It's gonna have an impact real soon. So if we predict focus location, you need to directly able to understand where is my epicenter, and the government should send you an emergency evacuation message to everybody. That's how things are done. The next part is known as fault. Fault is a crack caused by the focus. So if you think about where the plates meet and then where the focus is, the focus give you a little bit of shear effect. What I mean by that is, imagine here's a land and there is a focus. This is our focus. Then fault will be unexpected crack that happen. That is what I mean by the fault over here. When there's a plate meet, the rock is under great pressure, and rock cannot bend to a certain extent. I mean, pure metal can bend easily, but rock is more combination of minerals and metals, so it make it bend, and in the end there can be a crack. And if the crack is happening, that's what we call fault. So there are three types of fault. One of the type of fault is called normal fault. It happened because of the pulling action, ladies and gentlemen. So imagine a tug of war. I have a pulling that is happening towards the west, pulling that happened towards the right. Because of that, there is a breaking happening. Some of you guys may, doesn't it break like a broken rope? Just go left and right. Well, think about it. Earth is not a rope, so that analogy doesn't work. Rather, it decided to have a little fault in between, and generally it's diagonal because lighter material goes up, heavier material goes down, or depends on angle of the pulling. But in any case, this situation, we call it a normal fault. The next type is called reverse fault. Like the way it suggests, it's opposite of pulling. So it is pushing. So it is about compression. We have a pushing happening towards the east, pushing happening towards the west. Because of that, we have an impact on the mid side. So that's why we have a fault happening. We call it reverse fault. The next one is strike slip and transform fault. But this is more like a shear force, if you guys remember. It's a ripping. You have a one force that goes one direction and another one goes completely opposite. So that's a key thing, opposite direction, and that causes zigzag damage. We are almost at the end, folks, so let's pay attention a little bit more here. So how can we predict or measure the earthquake? There's a one device that humanity invented, and it's got way more better, but what you see in here is a very traditional version down there, and it's relatively more modern version. Still, we have better ones using computer design and development of technology. We call these machinery as seismograph. It's a fancy way of saying sesimo means earthquake. Graph is, can you see? Up and down like a line graph and impact graph. It's kind of like a sound wave if you know about multimedia. Same thing, ladies and gentlemen. We use seismograph to record the intensity of the earthquake. So because of that earthquake, ladies and gentlemen, it's kind of like this. Can you see that the weight is hanging by a suspended spring over there? If there's an earthquake, imagine it's going left or right, then the thing is, I'm putting a little line over here. This upper part do not move. But the bottom part is the one. Oops, sorry. Oh yeah, it is correct. I almost thought I looked at wrong. The bottom part does move because it is closest to the ground. Sorry, this is a ground over here. And table, if you will. So the funny thing is, imagine there's a shaking happen left and right. Then can you see there will be a rotating drum is what we call. There is a paper that go around like this, and that's the one that you see over here. This is a pen that is attached with the weight, except weight is a little bit hard to see in here. So because it moved left and right, can you see they are having a left and right sound wave looking graph over here? So right now we have quite a lot of big S wave over here. Quite small P wave. P wave is a weaker one, S wave is a larger one. So you can actually record the impact in there. Seismograph must be attached to the bedrock. Bedrock is the one that is most solid rock that lies right beneath the soil and is closest to the earth crust bottom portion. So they feel the vibration on the plates directly. And a marking pen, the one that I show right underneath the weight, record the vibration, and the drum rotates so that graph will be showing like smaller wave versus larger wave, smaller wave like that. Please know that this smaller wave should be P wave and the larger wave should be your S wave. The second wave is always big. Kind of like COVID situation. And the measurement scale we use is called Richter scale because Richter is the one who invented this technology. And it has a 0 to 10 level. If the level is located at 0, then there's almost nothing in there. As soon as you go with the first level all the way to 9 level, this is how impact is happening. So equivalent of kilogram of TNT. If you know what TNT is, that's dynamite. So if it's 1, that means 0.6 or 20 kilogram worth of dynamite that is being exploded, and that kind of energy. If it go all the way to 8, 60 billion kilogram of dynamite is exploding. So as you may notice, it is increasing, not a linear, we call it exponential increase. It increased like crazy. That is today's lesson, ladies and gentlemen. Your to-do list is basically doing science log activity number 6 and do textbook question 362, number 1, 2, and 3. That is your to-do list.